Section 7.5 is about rewriting logarithmic expressions. And we're going to go over some properties of logarithms, and you're going to learn 3 new ways how to rewrite logarithms. So in these 3 properties I'm going to give you, b, u, and v are just positive numbers, and b is not one. The first one we're going to talk about is the product property. What the product property says is that if you have log base whatever, and you have 2 numbers times each other, you can rewrite that in an expanded form. This is a condensed form, expanded form. You can expand that to log base b of u plus log base b of v. So really you're just splitting up the u and v's. The quotient property is very similar. If you have log base b of u divided by b, not b, instead of multiplication you have division now, you can rewrite that of log base b of u, and instead of plus, you subtract. So minus log base b of v. So you can expand that using subtraction. The power property says that if you have log base b of some number and you have an exponent, what you can do is bring that exponent out front. And that's what we did here in the expanded version. All we did was bring that exponent and write it in front of the log. So those are the 3 properties that we're going to use. First, let's use the properties of logs to approximate the following. The instructions tell us that log base 5 of 3 is approximately 0.683. And log base 5 of 7 is approximately 1.209. They want us to find log base 5 of 3 over 7. Well, the properties we just learned, we can use that to rewrite this and approximate the answer. If I have 3 divided by 7, division I can rewrite using subtraction. I can rewrite this as log base 5 of 3 minus log base 5 of 7. And the instructions have told me that log base 5 of 3 is about 0.683. So this is about 0.683 minus log base 5 of 7 is approximately 1.209. So this is about 1.209. And if I subtract that, I get negative 0.526. So log base 5 of 3 over 7 is approximately negative 0.526. Pretty simple. Now let's use the properties again to do log base 5 of 21. In the instructions, they gave us log base 5 of 3 and 7. Here we're trying to approximate log base 5 of 21. So the clue is that you need a 3 and a 7. And so you're going to have to rewrite 21 to look like 3 and 7. Well, 3 times 7 is 21. So you can rewrite this as log base 5 of 3 times 7, because 3 times 7 is 21. Well, using the properties we just talked about, multiplication can be rewritten as addition. So you can rewrite this as log base 5 of 3 plus log base 5 of 7. And then just add 0.683 plus 1.209, which is 1.892. And that's your answer. So let's try something with a couple more steps involved. We're going to expand this logarithmic function using the properties we know. First off, this is division, so we can rewrite it using subtraction. So log base 2 of 7x to the third minus log base 2 of y. The next step would be to see if you can expand either of these any further. Well, this one we can't expand it any further, but the first one has an exponent, and using the power rule we can bring this exponent down in front. So our final answer would be 3 log base 2 of 7x minus log base 2 of y. This would be our final answer. So this is fully expanded. Now let's talk about going in the opposite direction. So now we're going to condense the logarithmic expression. Your first step is to look for any exponents that have moved down and you need to move them back up. So here we have a 2 out in front of this log, so that means it was an exponent, so you need to move that back. So we have log of 6 plus log of 2 squared minus log 3. Now these first two, since they're added together, that means that it was multiplication. So to condense it, you can rewrite that as log of 6 times 2 squared minus log of 3. Now this subtraction means that you can rewrite this step as division. So you can rewrite this as log of whatever's in front of your minus is going to be your numerator, and this is going to be your denominator. So you're going to have 6 times 2 to the third over 3. And your final step is that you can simplify this by actually doing this math. So 2 to the third would be 8. 8 times 6 would then give us 48 over 3, which 48 divided by 3 is 16. So completely condensed, this is our answer. The last thing we're going to talk about is what's called the change of base formula. This is going to help us find logarithms with bases other than 10 or e. So in the formulas that I'm going to give you, u, b, and c are positive numbers and b or c are not 1. Okay, so if you have something that's written like this, you have log with base c of u, the change of base formula says that you're going to take log of this number over log of the base, and then you're going to be able to solve. And if you're using natural log, same thing, natural log of this number over natural log of the base. That's all that it says. It's pretty simple to use. So here we're going to use the change of base formula to solve for these. Change of base says you write log of this number over log of the base. So we have log base 10 of 7 over log base 10 of 3. We're doing this because we know how to solve log base 10, but log base 3, we don't really know how to solve for that. When we change it to base 10, then we can use our calculator. So if you were to type log of base 10, 7, log of 3 in your calculator, you'll get 1.7712. On the next one, same thing. To change the base so we can use our calculator, because our calculator doesn't really do base 4, it just does base 10. Change it to log of 8 divided by log of 4. And you can write 10 here if you want, but remember you don't have to write it if it's a 10 because it's just given that that's base 10. If you type log of 8 divided by log of 4 in your calculator, you get 1.5. So I want you to do the last one in your calculator, or if you don't have a calculator, wait till you get to class, click do it in the calculator, and we'll talk about what you get.